My fabulous chemistry faithful, video number 2, acids and bases. Today we're going to get into the vocabulary, 20 words, what they mean, how we're going to use them, so we can get on with this unit. So first, acidic. Here we go. Oh, cool picture of an acid reaction hitting a nylon, or that looks like a rubber glove hitting with acid. Check it out, pretty fun. Acidic means a solution with a pH lower than 7. It has an elevated concentration of H plus ions. Remember from last video, H plus and H3O plus mean the same thing. Then we're going to get into base. So you got an acid and I got a base eating up a Coca-Cola can. Fun. This is good stuff. This is a solution with a pH higher than 7, and it has an elevated concentration of OH minuses. So remember last video, we said OH minus means base, H plus means acid. Okay. Alkaline is another fancy name for base. So it's just another word for basic. If it's an alkaline, it is base. Okay. Arrhenius acid is the first thing we're going to learn about. By definition of arrhenius acid is a compound that produces H plus ions as the only positive ion in solution. So when these things dissociate, they're going to make plus ions and minus ions, and acids make H plus as the positive, and conversely, bases make OH minus as the only minus ion or negative ion. Okay, that is the original acid-base theory. It's called the Arrhenius theory. We're going to get into this on alternate base theory, which is called Bronsted-Lowry, in just a second. Hydronium, fancy word for H3O plus. Here's another picture before and after. Take an H plus, put it onto a water, you get an H3O plus. They're going to form this equilibrium. So if H3O plus is around, H plus is around, because they're always going to be going back and forth. Okay, so H3O plus is the hydronium ion. It means the same thing as H plus, which we need to know because this whole unit is about H pluses and OH minuses. Here is another picture of what I'm talking about. If you take an H off of a water and put it onto the other water, you make a hydronium and a hydroxide. So water itself, this is happening naturally, it's occurring naturally sometimes, and it's always going to be even, 1 for 1. Therefore, for every H plus or H3O plus that's created, an OH minus is created, and they balance each other out. So our pH is 7. Okay. A hydroxide ion is that OH ion. It is on table E. It is also a polyatomic ion. Okay. Alternate base theory. Here's why we need it. It's this thing called ammonia, which is NH3. There's a base that does not have OH in it. It makes OH by accepting this H. So it takes an H off of water. And then as you see in the product, I have what's called an ammonium ion, which is on table E, NH4 plus, and see that OH left? So that OH is not directly produced by the base, so that original theory from Arrhenius doesn't work. So the alternate acid-base theory explains why ammonia acts like a base without directly producing OH ions. There's no O in the chemical formula for NH3. But yet it's a base because it makes water into OH. Okay, here is the Bronsted-Lowry definition in picture form. Okay, acid now becomes a proton donor, base becomes a proton acceptor. We don't even talk about OH anymore in the Bronsted-Lowry theory. Bronsted-Lowry talks about acids as H plus donors, hence they give them off, which is very much in line with the other Arrhenius theory. But now a base becomes an H plus acceptor, creating OH in water. So now notice OH isn't even involved in the Bronsted-Lowry theory. It's all based on H plus. Electrolyte's a word we've had before. Here's a picture of what you did in lab. You put the solution in, it lit the light bulb. So this is any solute that dissociates, allowing the solution to conduct electricity. Okay, so that's what an electrolyte is. Acid-base indicator. This is a dye that changes color depending on pH. We are going to do a lab on this, investigating our indicators and figuring out an unknown pH. This is a GIF of what's happening when I take an acid and a base and I put them together. The HCl is the acid. The NaOH is the base. The NaCl makes salt, or a salt, because it's an ionic solid, and HOH is water. I'm going to refer to water a lot in this unit as HOH, just so we can see it come apart and go together easily. You can write H2O, of course, but I'll say HOH a lot, and it means the same thing. Acid plus a base reacts to produce water and a neutral salt. A neutral salt is a chemistry word for any ionic solid. Okay, neutral being it's a stable. I crisscrossed right and I got the right numbers. pH scale, classic color coding of one of the pH papers. So maybe something you guys used back in Living Environment. This is the negative log of the hydrogen ion concentration. We'll put brackets around that to indicate concentration. Measuring acidity and alkalinity from 1 to 14 is the range. So we'll get some number. Any number lower than 7 is acidic. Any number higher than 7 is basic, and we need to make sure we know that. Here is a GIF of someone doing an actual titration. This is what you guys will be doing in the second lab. You'll be doing just that. It will turn pink. It will go away. And when it turns pink and stays pink, you will be done. The titration is using the neutralization reaction. And we're going to put base in a burette. We're going to have acid of an unknown concentration. You'll know the volume. You'll be able to titrate to the end and back calculate and be able to calculate the concentration of the acid, because I'll tell you the concentration of the base. Salt, here's a bunch of them. All of these guys, if you look, metal, non-metal, these are all ionic solids. Okay, so a salt is a generic name for any ionic solid. Dissociate, I believe, is a word that we should know by now. We've seen it a few times. Dissociate is when the atoms of a solute break apart in solution, forming the electrolyte. It's the breaking down piece farther than dissolve. Lots of things dissolve, only ionics dissociate. Ions, we're going to re-see ions again. This is when an atom gains or loses an electron. This is all the way back from the first real unit of chemistry, atoms, after boot camp. Okay? Molarity. This is how we're going to use molarity in this particular unit. This is the M1V1, M2V2 equation. Molarity volume equals molarity volume. It actually, you're going to see it in your reference table. It says MAVA, molarity of the acid, volume of the acid, and then MBVB, molarity of the base, volume of the base. But this all is basically the same equation, and I can use it for dilutions too, which is cool. But it's also the titration equation. So this is molarity is moles of solute per liters of solvent. We learned that last unit specifically and had to do calculations. We will use those numbers this unit. Concentration, we learned about that last unit. It's how much? The amount of solute per solvent or solution. Okay, how much stuff is in there. And with that, we're done. There's your 20 words. Study up, take your vocab quiz, and let's move right along.